Hello everyone, my name is Michael Young and welcome back to Exapunks. So this game, I'm having a lot of fun with it. It's still losing points for not having a in-game language reference, forcing me to look at a PDF in another browser, but still it's a fun game. So we have a cutscene to speak with our neighbor.
Hello? You in there?
This voice, it's Isadora. I remember the name, but not much else. Isn't this someone I've known for a long time?
Hey, I brought you some snacks.
Do they have peanuts in them?
It's well, it's peanut blast, but without the peanuts.
This is gonna be a running gag, isn't it?
I guess there was some screw up at the factory, so now we have a bunch of these that we can't sell. Seemed like a waste to throw away. I hope you're doing okay. We should hang out again sometime. I don't have a lot of free time anymore, though. Working at Last Stop's really taken over my life. Speaking of which, I should get back. Take care, okay?
So, wait a minute. Gasped, glances around the room. Who am I? I'm on this list, aren't I? I must be. Am I this one? No, you're talking. It's gotta be someone. Am I Selenium Wolf? No. I must be this guy, Mutex. Because he's not talking, and I'm not talking. No, you're talking. Maybe I'm some sort of omniscient being that's able to see things even though I'm not in their room. Or maybe I'm Deadlock. No. I'm somebody on this list, I'm sure. Anyway, so far I have had to force the young woman who is helping me get meds to deliver me a pizza for free. Then I screwed over my next door neighbors at her job, and then the guy who was who printed me the reference manual for this, the local business that printed out this reference manual for the language I'm using is now not having to get paid for it. So that's a shame. I kind of feel like we're not like one of those good hacker types. Solve this puzzle to, okay. Change the message on an electronic highway sign. Would you change your behavior in response to stimuli? Of course I would. That may be fine. Would slogans printed on signs and posters in your environment affect your outlook on the world? Probably. I want to test something. Right lane closed ahead. Write Ember 2's message, file 300, to the highway sign. The file contains one character value for each position on the sign, from left to right, top to bottom. And there's a reference to the manual. Write the message to the sign, leave no trace. So like, wait a minute. Think about it. Think about what? Waiting for row. I'm not sure I get it. Once you're in, these signs accept messages in the form of a series of 3-number packets written to data. The first number is the row, starting at 0, the second is the column, starting at 0, and the third corresponds to the character you want to display. I'm not sure I see how this corresponds to think about it. Fight the power. I'm not getting it. 0069. The file contains one character value for each position on the sign. From oh, I see. I was thinking it was individual lights, but no. So fight the power. So it's 0012 FIGHT00. Okay, I get it. So a row is always 1, 2, 3, 4, 5, 6, 7, 8, 9 characters. Wonder what invis is. So clear screen clears the screen. Other signs have effects you can activate, like flashing or inverted text. So that's inverted. Anyway, let's go ahead and try this. So, well, this doesn't seem to be. Okay, wait. Think about it. Yeah. Okay, I get it. So, can we do this with just one exa? I think so. Well, no, because we're gonna have to do a double loop. Is it always gonna be this exact same input size? Like I can't tell, but I think it's always the same number of values. It's just that sometimes there's they're larger. All right. So there's something we can do there. We're guaranteed to get 3 lines of 9. See, it's easy to get the numbers written, but we need to do it. We need to supply a row and column. So, like, I need to send 0020 018. No, 0020 018 029, and so on. And I'm not sure how to store the loop values. So, invis has 0 in it now, and it has to have invis at the end. Do I need to make exas just to do the loop controls? I don't think so. That'd be weird. But maybe. Like, I can't store an I and a J. I only have the X. Well, let's try to do it with 1, and then we'll see where that causes a problem. Like, if need be, we can always. Yeah, I think we can do this because we know it's always going to be 3 rows. So this will do the entire thing. We'll just do 1. So go ahead, link through. Well, grab 300 first. Then link to 800. Then copy X to clear screen. Which will be empty, but it looks like it defaults to 0, so I think it's fine. Right? Yeah. Okay. Then we need to start feeding the data. We need to give it triples, or tuples of 3. So I'm gonna make X be our column control. So print call. So we're gonna begin. It already is beginning at 0. So let's see. So copy X. It's row call first, so copy 0 to data. Then copy X to data, and then copy F to data. And we're gonna have to do a checkup here. So test if X greater than 9, because we can't print beyond the 9th character, right? So if it's greater than 9, so true jump to print call 2. And we'll mark that right here. Mark print call 2. And let's just call this print call 1. So otherwise, once we've copied these 3 in, go ahead, increment X. So addy X, 1, X, and then jump print call 1. Let's just see if that works. So X is not greater than 9. So copy in a 0, and what am I even doing? Waiting for row. Okay, there's the T, and we're looking for a think about it, so it's working. Think. That's gonna do the 0s, so. And now it got to the 9. It's gonna test to see if it's greater than 9. Or should it be equal? Yeah, it's equal. Okay. So if X equals 9, because it's a programmer thing, so it's the 9 slots are labeled 0 through 8. Okay. Oops. So we could have a second EXA a second one of these little bots that would just store the column, or we could just duplicate this 3 times. And I think I'm gonna go with this at first, just because it's kind of simpler. And we'll see if it works, and if it's, you know, terrible compared to other people, then we'll optimize. Go to finish. And then mark, finish, halt. Yeah, halt. That's fine. No, we have to wipe. And then halt. Oops. There. How'd that work? He said you hold shift and then press... I don't remember. Here, go ahead. It failed. Oh, we need to reset it back to 0. How are we gonna do that? I can't reset every loop. I need to reset at the start of the loop. So this is a bit more annoying. We're like taking up more space. Oops. And this has to go to start 2. Oh, I feel like maybe we're not doing this right. Like, this is gonna be a horribly unoptimized thing. But oh well. I just tried to right quit it. I didn't go to the right one. So these are copying in 1, not 10, not 0. And these will copy in 2. There. There we go. Yep, that's what other people were doing too. Activity is low. But apparently I was still slower than most people. Oh well. It's good enough. It works. Excellent. That was a great test. Now we just have to take the data, separate the multiple experimental conditions, isolate the processing. Okay, I have no idea what to do with this data. How about if you notice more people questioning authority? Let me know. Another meeting? Okay, they told me at one point to avoid hitting tab. Stop doing that. Stop it. Okay, come on. Come on, finish up. There you go. Alt-click an instruction. Okay, we'll have to remember that next time. Play the cutscene.
I have an important question for you.
Oh. Okay.
Imagine there's an out-of-control trolley, and 5 humans tied up on the track ahead of it.
I gotta admit, I didn't think of you as a woman. I thought for some reason I thought you were a young man. But I mean, you're obviously an AI, but still.
But you can stop the trolley by...
By kicking a fat man out onto it.
Maybe if... No, that wasn't the one I was going to ask. Recalibrating. Say you had a friend, and you knew the friend could help you become stronger. Would you ask for their help?
Sure. I don't know enough about the situation to say.
Let's say it was a situation where the friend had to sacrifice something in order for that to occur.
Well, then you're no good friend.
Okay, good to know. I'm going to process this information.
You don't ask your friends to sacrifice for you. Find and retrieve a specific file for Ember 2. Can friendship exist without self-interest? You talk about friendship a lot. You're not my friend, you're my employer. It seems like a useful concept to understand. No reason other than that. There is a particular file I need you to locate here. Don't concern yourself whatever else you may happen to see. It's all obsolete. Is that Russian? I don't know. Okay. Find file 276 in the network and bring it back to your host. Note that an EXA cannot grab a file that is being held by another EXA. Well, I mean, how do I make you not do what you're doing? Like, I have no idea what's going on here. we need to, like, maybe we can just pick it up? I mean, that's another EXA. Oh, maybe... Maybe we can reference it once we get up to it? Like, we could tell it to do stuff? Like, I can kill it, perhaps? Here, go ahead. Let's just get up there. So, link to 800. This isn't gonna work, of course. Link to 801. Link to 801. I just want to see what happens. And now, how do I kill you? Terminate. Okay, kill. Terminate another EXA in the same host. Prioritizing EXAs created by the same user. Okay, let's try that. Just get there and kill it. It didn't work. Oh, it did. And then there's a 276. Is it always 276? Yes, it's always 276. Okay. So... Okay. So we want to create an EXA that either goes to 800 or 801. So... So if it's going to an 800, let's see. So this will be the 800-ish way. If it goes there, it links 800. And let's see. Then it... Like, I clearly need to replicate and make another one that's just like me. Okay, wait a minute. Let's do this. Let's say I'm gonna have two targets at the very bottom. So one of them, well, okay, we're gonna have a traverse phase, and we're gonna have a path 800, and a path 801 phase. And this one is gonna start, the first one is gonna be an 800. So jump, path 800. And as an 800, I'm going to, copy 800 into my X. And then I'm going to link X. As an 801, I'm gonna copy... Oh, and then I'm going to jump to traverse. As an 801... Well, I don't even need a link X. I can do that in traverse. So copy 801 into X, and then jump, traverse. Okay. Now, when it's traversing, it's going to link to its X, and then make a copy of itself. So repla, make a copy of itself that starts at the 801. Path 801. Well, wait a minute. It needs to... Like, how am I gonna know to stop? Maybe I should make 2 copies of myself, and then if both of them fail, well, alright, let's try something else. Let's just, here, you, can I just, like, make you, can I make you stop? Here, wait, so, just halt at the top. Create a new EXA, and I just want to test something, so, link to 800, and then try to kill. Will you kill yourself? Let's find out. Okay, you're in 800, and now kill. Yes, you killed yourself. Maybe not. Maybe it just ran out of things to execute. So, do no ops for a while, just to see if you die. No, you don't die. Okay. I think I am gonna create an extra one out here. I'll make all of them try to find the file. Like, maybe this is a little lazy. I'm creating a lot more EXAs than I need to. I'm looking through the manual, seeing if it can give me any hints. Okay, say you were looking for a specific file, the EXA that tries it will terminate, but now you know the file isn't there. Say you were looking for a specific link, the EXA that tries it will terminate, but now you know the link isn't there. How will I know the link isn't there? Because I can't test to see if there's an EXA around. So I could use the M thing to do a local test. No, that'd be a bad idea. Well, I know it's always 3 down. It's 1, 2, 3. So I could just store a value. I think that's what we'll do. Go away. So, well, but we're using the X to know where to traverse. Let's not do that then. We'll put the link command down here. So, oops, link 800, and this will link 801. And let's see. So X is gonna start out at 0, and we're gonna go forward and now 1, 2. Well, okay. So let's just start here. Jump 800, and that will begin, and then copy X. Well, traverse, the first thing we should do is increment X. So, addy X1X. and then test x equals 3. And if true, then retrieve. Well, true jump. Jump to retrieve. And we'll mark this as a separate path. Okay, so, but if it's not 3, then create a replica going the 801 path and then go yourself the 800 path. Jump. Path 800. Right? Let's see what this does. It's a little tricky. So, link 800. Now you're in traverse. So x is now 1. X is not 3. So create a replica. Why is x... Okay, x is still... okay, it's a 0th child of xa. Now this one is going to jump to 0, and this one is going to jump to over there. So, okay. Now the same thing happens again. Now x is 2 on both of them. So you're creating a replica, sending one way, one the other. Now x is 3. Okay, so it should be testing for x equals 4. Okay, when we get there, let's just put some in there. So, kill. Okay, so eventually you're gonna have one everywhere, and one of them is gonna be able to kill. And then they're out of instructions. Well, they're all gonna try to kill once they're down there. So kill and then try to grab. It's always 276. And then link -1, -1, -1. So 1, 2, 3, and 4, and then halt. So you killed it. Now you grabbed it and you bring it back. Bit slower than average. Oh well. Would you say you had friends? I don't remember. Not really. I'm like, my entire system is all wrecked with this phage, so I don't remember anything. Perhaps you can make an effort to meet new people. Like, my arm doesn't even work, man. I have to hack my arm to make it do stuff. By posting a personal ad, for example. Either way, this is good data for me. A number that just beeps. Some kind of government beep. A number station. UC Berkeley. Restore a file from an antiquated backup system. There's another file I want to grab. They tried to wipe everything clean, but luckily there's a set of backups. Always keep a backup, right? Right. You never know what's gonna happen. Data is more fragile than people think. Okay, locate the specified host, tape 1, 2, or 3, and then locate the specified entry, something in Russian, in the tape backup in that host. Create a file in your host containing the entry's data. The names of the target host and entry are available in file 300. Okay, and it sends me as a reference into the manual. Okay. Each tape contains 0 or more backup entries. The data for these entries starts at the beginning of the tape and is concatenated sequentially, making it impossible to tell which data belongs to which backup entry. It's going to take some work to retrieve that data. Really? That seems like a terrible system. Metadata for the entries is stored at the end of the file in 3-value triplets. The first value is the entry's name. The second value is the offset in the data stream where the data entry starts, and the third value is the length of the entry. For example, to get the data for an entry with metadata secret 34, you go to the beginning of the file, skip the first 3 values, then read off the next 4 values. Alright. I don't know, this isn't... never mind. Let's just figure this out. So... it's gonna tell us different tapes to use? Yeah, sometimes it's tape 2. And... like, how do we know where to go for that? What's in 243? Names. PII. Things we cannot allow. Okay, so the way this works, I'm looking for, like in this one, it would be in tape 3. I'm looking for this code, knacker, whatever it is. It's telling me it's the values 55, 18. So do I need to grab the 55th one of these and then another 18, or do I need to grab the 55th character in these? Let's see, these are 5, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's fine. We can deal with that. But I'm still not sure how to deal with finding the right one. I mean, there's gotta be a command I don't know. So... host R. Copy the name of the current host into the specified register. Okay. And it's one way. So I can't go this way. I have to just keep going around. That's convenient. I get it. Okay, so we keep going around, copying the host name into the register until we get to the one that's this first item. Okay, let's just begin this. We might need to do more complicated things, but for now, why is it not working? Right. So grab 300 and link link 800, and there's nothing to do here, so link 800. Well, I really just need to keep going around until the host name is right. Into the specified register. Like, I'm trying to avoid too many reads, but I think that's lazy of me. I should just go ahead and keep reading it over and over again. So, let's make a new area. Mark find server. Or find host. And to do that, we check to see what our current host is. Host X. Then test X equals F. Then no matter what you want to do, you want to seek, well, if you're there, you don't need to seek back. So F, true jump, then you do your file manip. What are we doing in this case? We are extracting. I'll just say file manip. But if you did not, well, we'll mark it down here. Fail manip. If you didn't find it, then you want to seek back one. And link 800. And then find host. Let's test if that works. So like we're doing a lot of comparisons we don't need to. I'm gonna go ahead and get us to the first one before we begin this. So link 800, link 800, link 800. So 1, 2, 3. We're right here now. Now we'll begin checking. So we're in tape 1. Tape 1 is not tape 3. So go back and go forward twice. It's always twice. Oops. We're adding more lines, but we're making it more efficient. Reducing cycles by adding lines. Okay, now we're in the right place. So we go to File Manip, and don't have anything to do. So in File Manip, once we're there, we need to do some mess with this 200. Unfortunately, how are we gonna do this? Because we're gonna need to walk it. Okay, wait, no, we can do this. So, go ahead and copy from the file into X. So X now contains as the name that we need. And then wipe the file and grab 200. You know, we're gonna need to copy this somewhere. We're bringing it back to in my house. So I'm gonna need another. Here, you get the data, and you copy the data. So you're sitting here for now while you're gonna make a file, and like, yeah, it says new. Oh, it says do we need to leave the 300 there? Like, it's saying the goal is to have the 300 still there. I don't know, I don't believe it. You're not supposed to leave the 300 there. I'm gonna try it without, and then if we do, we'll end up seeing. And what does this lock mean? Does that mean we can't lift it? Or it's read only. That makes sense. So make a file, and you already have it. So you're going to we're gonna have to have a communicator to figure out what value to send. How are we gonna know when to stop? That's what I'm saying. Oh, I guess we'll send the number. We'll send the number, yeah. I guess? How are we gonna do this? Because we're gonna have to store 2 things from the file, and then, let's see, and then pass one of them. So we're gonna have a guy out here, and he's gonna say it's going to be 15 characters from slot 4. And I need to store both the 4 and the 15. I guess what I'm gonna have to do is grab the 15, send it back home, then use the 4 to jump in my file, then get the 15. Do I want to get the 15? Like, what do I do if I had it? If I had it in my X, then I'd know that'd be my loop control. Okay, yeah, that'll work. That'll work. It's messy. I don't like it. Let's try it. Let's try it. So, make a file, and then you're going to copy the first thing you get to your X. Copy M to X, and then you're going to copy it right back. You're going to give it back to the other guy. And then the rest of it, and you're also going to have to do stuff with it. So, mark, loop, right loop. Subtract X. 1x, then test x. We can do that at the end. So, well, we can do it now. Test x. No, it makes more sense to do it after. So down here, test x equals -1 or 0. It's be 15 characters, so there'll be a 15. Okay, so if it's equal to 0, then if it's false, so false jump to the right loop. Otherwise, halt. I think that works. I don't know. We'll see. When we have it, we actually have to write it to the file now. So, copy from M to F. Let's see if that works there. So, well, now we actually have to send it, of course. So, now that we're there, we've got the file, we're holding it. Now we have to find in the 200 the right place. It's going to be one of these at the end. It won't necessarily be the last one. So let's just create a little logical thing. It's not actually going to be a reference thing. So find string, which I have in my X register right now. Yeah, because X has the name right now. So seek the end. Well, let's start out by seeking the end. Seek 9999. And now we step back to seek -2. So it'll be on this one, and then we'll say go back to, and now we're on the name. So test. trying to see if I can avoid that seek -2 somewhere. I don't think I can. I think I'm gonna have to do that because this test is gonna move forward and I'll have to go back 4, not just 2. So this is fine. So test if x equals f, and if it does, then we have to extract. So t jump to extract data, which will make a little header for down here. If it's not, then seek -4, right? So it's going to be, okay, we just checked to see if it's this. So now we're pointing here. So we have to go 1, 2, 3, 4 to get to the one prior. Seek -4, and then jump to find string. I think that works. So that will be in the right place at extract data. At extract data, we're gonna be pointing at the number, this number, which I need to store as my x. Okay, so copy fx, and then store the number of characters to the other bot. Okay, now while the other bot holds that value, we're gonna jump to the right place in the file. So seek. Well, we don't even need to write back. Yeah, we don't need to write back. What am I thinking? We can just seek right here. No, we're not. We're gonna have to write it back because we can't access this twice. Or we could. We'd have to seek back, though. Does the other one even need to know the file size? It kinda does. What am I storing? I'm storing the location. I don't need to store the location. Why would I store the location? I can just seek straight to it. So seek f. No, I need to store it. Okay, never mind. I am wrong. I am just all wrong. Because we need to grab it and then Okay, so say we found the string. We found the string. We're sitting on the next character, which is let me just double check this to make sure that it is the location first. Yes. So it is the location first. And so seek one forward, then copy f. Does this make any sense at all? Copy f to x. I'm trying to figure out this communication. I think we are gonna have to send something back to it, since we can't store it. No, we could do this. We could do this. So we copied. Okay, so now we're looking at the 18. We just copied it into X. And now we're looking at the end of the file. So we're gonna seek back 1 to the 18 to the 55. We need to seek back 2. And let's go ahead and copy that over to M. I think. And then we'll seek F. I think that'll work. Here, let's just see. Let's just nope it, no op it, and see what happens when we get down here. So get to there, and so now we're looking at the 55. We're testing to see if that's equal to. Is that the right? We should be testing if it's equal to 55. That's not. That doesn't make any sense at all. We're off by 1 somehow. Wait a minute. So wipe the file, grab the new file, seek the last one. So we're beyond the end of the file, and then seek -2 puts you there. I need that to be -3. Okay, so now we're looking at the right name. Now we test to see if that is equal to our string, which in this case it is. So now we seek 1 to get to the 18, copy it, go back to the 55, send the 18 over, and now you're sitting on the 18. And now you're seeking. It didn't work. Seek F. It didn't work. Why didn't it work? I thought I'd be back here now. I thought I'd be at the 18th spot. Oh, and okay. Wait a minute. It's trying to send it forward, so we need to seek to back to the beginning, which means I do need to store it. Damn. Okay. So yes, let's copy it back to me. Copy X to M. There's got to be a better way to do it than this. I'm screwing something up, but oh well. I think it's gonna work. So seek -9999 to get to the beginning of the file. Or honestly, seek, well, that would guarantee if it's a really long file that you get back to 0. So that makes sense. So copy fx, then seek -99, then seek x. And now copy m back to x. Okay, so at the end of this, I should be in the right spot, and I should have an x will be the number of characters I have to read, and your x will be the number of characters I have to write. So let's see if we can do that. Sorry. Okay, so we're at 55. We're looking at the 18, and we capture it. You know. Okay, well, we can optimize this a little bit. We don't need to store an X anymore. We can just copy it straight over. Okay, give you 18. And now you're gonna jump back to the 55. And now we'll store that. Then go to the beginning of the file, and then go forward 55. And now I get my 18 back. Yeah, okay, that works. Okay, now I'm there. I need to go ahead and set up a loop to copy over. So mark copy over. I really want to do a while loop, but that's not what you do in this. So subby x1 x copy fm. I keep trying to put it in caps by holding shift. It's a waste. If x equals 0, then you are done. If it does not equal 0, then go to copy over. Halt. Half. Alright. So let's see if this is working. So this file should get a copy of this. And exactly where should it end? It should end at the 4104. No, it should end at the 2757. Let's see if we're an off by 1 sort of thing. No. Hey, it worked. Let's see if it works on the rest. Yeah. And we're actually, you know, up there. We're using more space, like, but I think that's all, you know, code clarity. All the seeking around, I don't think that was necessary. But we got there, and we did it in the typical number of steps. Typical number of cycles, I guess. We're just bigger than most of the rest of the people that play this game. Oh well. Kind of a shame what happened here. There was some interesting research going on. What did happen? Oh, you know, people get swapped around, priorities change, things don't work out for lots of reasons. Okay, we're well over time, so I better stop here. I probably should have broken the last puzzle into a different part, but I didn't think it would take that long. So thank you everyone for watching. Till next time.